Hello everyone, welcome back. Now let us solve a GATE 2026 question step by step. Before solving a circuit problem, the first thing we should learn is how to choose the right analysis method. In this question, we need to find the output voltage V0. Since V0 is a node voltage, nodal analysis is a convenient choice. There is also a 6-volt independent voltage source connected between two unknown nodes. This is exactly where the supernode concept is useful. So let's solve the question using nodal analysis and a supernode. The question in consideration is the output voltage V0 in volts for the network shown in the figure is. Round your answer to 2 decimal places. At the first glance, we can see that the circuit has a 1 milliamps independent current source, 4 1 kilo ohm resistors, a 6-volt independent voltage source between the two middle nodes. The output voltage V0 measured between the top and bottom nodes with the top terminal positive. Now let us start solving this particular problem. Step 1. Identify the nodes. That is, first choose the bottom wire as our reference node or ground. Therefore, voltage at the bottom will be equal to 0 volts. Now we have three unknown node voltages, top node being V0, left middle node equal to V1, right middle node equal to V2. Also, every resistor has a value of 1 kilo ohm. Our goal is to find V0. Now we'll move ahead with step 2, which is nothing but we need to apply KCL at the top node. First, notice that the upper ends of both resistors are connected to the same continuous wire. Since an ideal wire has no voltage drop, all points on this wire are at same potential. Therefore, the upper end of both resistors is at V0. The lower ends are at V1 and V2 respectively. So current through the left resistor flowing from V0 towards V1 is V0 minus V1 divided by 1 kilo ohm. Similarly, the current through the right resistor flowing from V0 towards V2 is V0 minus V2 divided by 1 kilo ohm. The 1 milliamp current source points upwards, so it injects 1 milliamps into the top node. Therefore, by KCL, V0 minus V1 divided by 1 kilo ohm plus V0 minus V2 divided by 1 kilo ohm equal to 1 milliamps. Multiplying throughout by 1 kilo ohm, we get V0 minus V1 plus V0 minus V2 equal to 1. Simplifying it, we obtain 2V0 minus V1 minus V2 equal to 1. This is our very first equation. Now we come to step 3, where we need to identify the supernode. Here comes the important part of this question. The 6-volt voltage source is connected directly between V1 and V2. Both V1 and V2 are unknown nodes. When an ideal voltage source is connected between the two unknown non-reference nodes, we combine those two nodes and the voltage source into one larger node called a supernode. Why do we do this? Because we cannot directly write the current through an ideal voltage source using I equal to V by R or through Ohm's law. Since an ideal voltage source doesn't have a resistance value. Instead, we apply KCL around the outer boundary of the supernode. Step 4. Apply KCL to the supernode. Now, let's apply KCL to the supernode. We only consider the elements that connect the supernode to the rest of the circuit. There are 4 such branches. From V1 towards V0, we obtain the equation V1 minus V0 divided by 1 kilo ohm. From V1 towards ground, we have V1 divided by 1 kilo ohm. From V2 towards V0, we have V2 minus V0 divided by 1 kilo ohm. From V2 towards ground, we have V2 divided by 1 kilo ohm. Applying KCL, the algebraic sum of all currents crossing the supernode boundary is 0. That's why we obtain V1 minus V0 divided by 1 kilo ohm plus V1 divided by 1 kilo ohm plus V2 minus V0 divided by 1 kilo ohm plus V2 divided by 1 kilo ohm equal to 0. Multiplying throughout by 1 kilo ohm, we obtain V1 minus V0 plus V1 plus V2 minus V0 plus V2 equal to 0. Simplifying it, we get 2V1 plus 2V2 minus 2V0 equal to 0. When we divide by 2, V1 plus V2 is equal to V0 is the second equation that we obtain. Notice something important here. We don't actually need to find V1 and V2 individually. In order to find V0, which is our final step, from equation 1 we have 2V0 minus V1 minus V2 equal to 1, and from equation 2 we have V1 plus V2 equal to V0. So substituting V1 plus V2 equal to V0 into equation 1, we get 2V0 minus of V1 plus V2 equal to 1, which is 2V0 minus V0 is 1, or in other words, V0 equal to 1 volt. The question asks for the answer to 2 decimal places. Therefore, V0 equal to 1.00 volt. This is the final answer to this particular question.